Welcome to Tech Info. Agricultural robots have proven to be a valuable tool for farmers around the world. Learn how they automate and improve farming, and where to source them. Agriculture has become increasingly mechanized and automated since the Industrial Revolution. Artificial intelligence brings this automation to an even higher level. The use of AI intersects what is now called precision agriculture. It is all about reducing inputs such as fertilizer, pesticides, herbicides, and water while increasing yields. The worldwide annual market for agricultural robots was estimated to be $24.5 billion in 2021. It was projected to grow to $74.5 billion in 2024. Aerial imaging robots. Using aerial drones to inspect crops from the air is well established. Aerial imaging produces valuable insights into crop health and soil conditions. The accepted way to monitor crop growth is to use Normalized Difference Vegetation Index (NDVI) maps. But it's not just a question of passively examining the data. The NDVI data can be downloaded to tractors. Smart farm equipment uses the data to control the application of fertilizers. There is a robust market for aerial drones for agriculture, with many options from which to choose. Types of aerial drones for agriculture. There are three main types of unmanned aerial vehicles, UAVs, used in agriculture. Fixed-wing drones. A fixed-wing drone has wings like an airplane and often only one or two propellers. Such a drone can stay aloft for longer than rotary-wing types. Long flight time is an advantage for today's vast farms. But they need a smooth strip for takeoff and landing and are more difficult to pilot than copters. Rotary-wing drones. Rotary-wing drones have multiple rotors with blades like helicopters. The most common configurations feature 4 rotors, quadcopters, or 6 rotors. Some drones have many more. Rotary-wing drones are easier to control than fixed-wing. Because they can take off and land vertically, they do not need landing strips. Rotary-wing drones are usually less expensive than fixed-wing models. Hybrid drones. Hybrid drones take off vertically and then can switch to a gliding mode while in flight. They therefore combine the advantages of the other two kinds of drones. Hybrid drones promise the longer flight time of the fixed-wing drone and the ease of use of the rotary-wing types. However, hybrid drones are more complex, heavier, and more expensive. The technology is also not as mature as for the other two types. Types of sensors used in agricultural drones. RGB cameras. An RGB sensor is also called a true color camera. RGB sensors are so named because they detect light in 3 components: red, green, and blue. The images produced by RGB cameras are like human vision. Multispectral cameras. As the name implies, multispectral sensors detect light in a band of frequencies. 2 especially useful bands of frequencies for agriculture include infrared and the red edge band. Thermal. Thermal cameras help in detecting plant stress, especially water stress. LiDAR. Light detection and ranging sensors are heavier and more expensive than the other 3 types of sensors mentioned above. They are used to map terrain elevations and are more often deployed on manned aircraft. Thank you for listening.